This one drawing runs an entire building, and every mark on it is a single line diagram symbol. Look here. This box is a circuit breaker. These two coils are a transformer. That whole strip of power is drawn as one line. That is the trick a single line diagram plays. And once you can read it, you can read how any facility gets its electricity. Right now, it looks like a wall of little shapes. It is not. Every symbol on a one line belongs to one of a few families: sources, protection, transformers, the busbar, instruments, and loads. Learn the families, and a strange power drawing suddenly has a shape you recognize. So we will walk all of them one at a time, and then read a real single-line diagram from top to bottom. Let us build the whole legend. First, the single most important idea. Why is it called a one-line or single-line diagram? Real power is three-phase, 3 live conductors, plus a neutral and an earth. Drawing all of those would be a mess of parallel lines. So the one-line convention draws the whole three-phase run as a single line. One stroke on the page stands for all 3 phases at once. Little tick marks across a line, or a small number beside it, tell you how many conductors that single line really carries. That is the whole simplification. A single line diagram is a map of the power path, from the utility, through protection and transformers, down to every load, with the 3-phase detail collapsed into one clean line you can actually follow. Quick note before the tour. Every symbol you are about to see also lives in a free chart on the site. It is searchable. It is printable. It costs nothing. Keep it open in a second tab and follow along. The link is right below. Right. Let's start at the top of the drawing, where the power comes in. Group 1, the source and the protection. This is the top of every single line diagram where power enters. First, the utility source, or incomer. It is the grid connection drawn as an arrow or a small network symbol feeding in from the top, the point where your drawing meets the utility. Right below it sits the main protection. A circuit breaker is a square or a small box on the line, a switch that trips and clears a fault. On a big incomer, it is often a draw-out breaker, shown with little carriage arrows because the whole breaker rolls out of the switchgear. Downstream, a molded case breaker, or MCCB, protects a feeder. Same idea, smaller box. The older cousin is the fuse, drawn as a slim rectangle on the line, a link that melts to break the circuit. And a disconnect, or isolator switch, is a break in a line with an open blade. It is not a breaker. It only isolates a dead circuit, so it is safe to work on. Source, breaker, fuse, disconnect. Everything that feeds and guards the top of the drawing. Group 2, the transformer and the busbar. This is the spine of the whole one line. A transformer is 2 coils drawn side by side, or as 2 interlocking circles, the 2 windings. It steps the voltage up or down, and the label beside it tells you the ratio, say 11 kilovolts down to 400 volts. This is the 2-winding transformer, the most common one you will meet. Below the transformer sits the busbar, drawn as a thick, heavy horizontal line. Think of it as the distribution rail, the solid bar of copper that every feeder taps off. Power comes down from the transformer, lands on the bus, and then splits out to all the circuits below. The transformer feeds the bus. The bus feeds everything else. Get those 2, and you have the backbone of any single-line diagram. Group 3, the instruments. These are how the drawing measures and protects itself. A current transformer, or CT, is a small circle sitting on the line. It clamps around a conductor and produces a tiny copy of the current for the meters and relays. A potential transformer, or PT, sometimes called a VT, is a pair of small circles tapped across the line. It scales the high voltage down to a safe level to measure. Both of these are instrument transformers. They exist only to feed information to the protection. And that protection is the relay, often drawn as a circle or a box with a code number inside, like 50 for overcurrent or 87 for a differential. The relay watches the CT and PT, and when something is wrong, it tells the breaker to trip. CT, PT, relay, the sensing and protection layer of the one line. Group 4, the loads and the sources that are not the grid. These hang off the bottom of the drawing. A motor is a circle with a capital M inside, the classic one. It is the biggest single load in most industrial one lines, and it sits at the very end of a feeder. A generator is the same circle with a capital G, an on-site source that can feed the bus when the utility is out. Standby generators, solar inverters, and turbines all show up this way. Then the capacitor bank, drawn as two parallel plates, sometimes stacked in a group, is not a load in the usual sense. It sits on the bus to correct power factor and hold the voltage up. Motor, generator, capacitor bank, the working ends of the single-line diagram. Group 5, the connections that tie it all together. Small marks, but they change the meaning of the whole drawing. Earth, or ground, is the safety reference, drawn as shrinking horizontal lines, the same symbol you see everywhere in electrical work. On a one line, it marks the neutral point of the transformer and the main earthing of the installation. A feeder is simply the line that carries power from the bus down to a load or to another board. Where it leaves the drawing to another sheet, it ends in a small arrow or a tag. And remember the one-line convention. Those little ticks across a feeder tell you how many conductors it really has. 3 ticks, 3 phases. Earth, feeder, and the conductor ticks, the connective tissue of the drawing. Now let us put it together and read a real single-line diagram, top to bottom, because that is exactly how you read one. Start at the top. The utility source feeds in. Straight below it, the main circuit breaker, the one switch that isolates the whole installation. Below the breaker, the transformer steps the incoming voltage down to a usable level. Its output lands on the busbar, that thick horizontal rail across the middle. Now read across the bus. Each feeder drops down from it through its own breaker, one to a motor drawn with its M in a circle, one to a distribution board, one to a capacitor bank holding the power factor up. On the incomer, you can see the CT and PT feeding a relay that guards the main breaker. That is the whole story of the building's power in one picture. Utility, main breaker, transformer, bus, feeders, top to bottom, source to load. Read it in that order, and any single-line diagram, however busy, unfolds in the same way. So where do you find all of these when you need them? Right here, in a free editor that runs in your browser. Open the symbol library, and every part we just covered is one search away. Type breaker or transformer or motor, and there it is. Filter to the power set, and you get the whole single-line family. Sources, breakers, transformers, bus bars, instrument transformers, and loads. Hundreds of symbols, ready to drop straight onto the canvas. This is the honest way to learn them. Do not just watch. Open a blank sheet, search for a symbol, place it, and wire it into a bus. 10 minutes of building beats an hour of memorizing. Everything you have seen is drawn in this exact tool, and it is completely free. So here is the whole legend in one breath and one printable grid. Sources and protection sit at the top. The utility incomer, the circuit breaker, the fuse, and the disconnect. The transformer and the bus bar are the spine, 2 windings feeding a thick distribution rail. The instruments watch everything, the CT and PT feeding a relay. The loads hang off the bottom, the motor with its M, the generator with its G, and the capacitor bank on the bus. And earth, feeders, and the conductor ticks tie the whole thing together. Read it top to bottom. Utility, breaker, transformer, bus, feeders, and a single line diagram is no longer a wall of shapes. It is a map of the power. Keep the chart open the first few times. After a week of reading real drawings, you'll not need it. Open Circuit Diagram Maker.app, pick any diagram, and start reading. It is free, it runs in your browser, and the link is right below. Subscribe if this finally made single line diagrams make sense, and I will see you in the next one.